What is the gradient in backpropagation for neural networks? Imagine trying to find the best way to adjust a recipe so that your cake turns out perfect every time. In neural networks, this recipe involves tweaking many little ingredients called weights and biases. But how do we know which way to change each ingredient? That's where the gradient comes in. The gradient is like a set of directions that tell us how much each weight and bias should be adjusted to make the network better at its task. It's a collection of partial derivatives, which means it shows how small changes in each parameter will affect the overall error or loss of the network's predictions. Think of it as a map that guides us to the lowest point in a hilly landscape, which in this case is the point where the network makes the fewest mistakes. Backpropagation is the method that finds these directions efficiently. It works by starting at the output layer, where the network's prediction is compared to the real answer. It measures the error, then moves backward through each layer, calculating how each weight and bias contributed to that error. This process uses the chain rule of calculus, which helps break down complex derivatives into manageable parts. So, the gradient tells us how much to change each weight and bias to reduce the error. If a certain weight causes the error to go up when increased, the gradient will suggest decreasing it. Conversely, if increasing a weight reduces the error, the gradient will point in that direction. This information is then used by optimization algorithms like gradient descent, which update the parameters step by step to improve the network's accuracy. Understanding the gradient is essential for training deep learning models used in many AI applications today. For example, models like ChatGPT, DALL-E, and Midjourney relying on these calculations to learn from vast amounts of data. The more accurately we compute the gradient, the faster and more effectively the network learns. It's also important to consider the ethics of this process. Since neural networks learn by adjusting millions of parameters based on data, biases in that data can influence the model's behavior. Ensuring transparency and fairness in how these gradients are used helps build responsible AI systems. In short, the gradient in backpropagation is the key to guiding neural networks toward better performance. It's the mathematical compass that helps these models learn from mistakes and improve over time, powering many of today's most advanced AI tools.